Hi you guys, it's Miss Pruitt, and I am bringing you a video on Riemann sums of unequal widths. So let f be continuous and non-negative on the closed interval AB. Then a Riemann sum can be used to find an approximate area of f under the curve if the widths of the rectangles are unequal by taking each of the areas. That's what this is describing. Take the area of the first rectangle, take the area of the next one, and just add them all together. The number of blanks is going to be your total number of rectangles. Each blank is going to have the area, where you find that by taking its height times its change in x, or the change in x, or its f of x value versus the difference between the x values of each rectangle, where delta x is different for each rectangle. And 3, the heights are determined by the problem situation. If it is a left or right Riemann sum, you're going to take that value at the corner of that rectangle. If it's a midpoint, well, you're going to take that value at the midpoint. So here is an example problem. It's actually a free response problem from an AP exam. It says the rate of fuel consumption in gallons per minute recorded during a plane flight is given by a twice differentiable function r of time t minutes. And here's the first question. Approximate the value of the total fuel consumption using a left Riemann sum with 5 subintervals indicated in the table above. So it's giving me my intervals already. It's pretty easy. I'm going to take a line, vertical lines, and just separate this graph out. That one wasn't very cute. Separate them all out. Make it easier for me to do my Riemann sums. It's telling me I need 5 subintervals. So there goes 1, 2, 3, 4, 5. And they're getting this information from this table right here. All right, so I am going to approximate the area under this curve by taking shapes that I can deal with, which are the rectangles, finding those areas, and then adding them together. So in this case, these subintervals, starting with a left Riemann sum, dealing with the first rectangle, it has a change of x, that's 30, times its, well, hold on, I don't want to write too big. Change of x of 30 and a height of 20. That's how do you find the area of a rectangle, right? Length times width, plus the second one, which is going to be 10 times 30, plus the next one, which is going to be 10 times 40, plus the next one, which is 20 times 55, plus the last rectangle, which would be 20 times 65. And surely I can use a calculator, and I would get that this equals 3,700 gallons. Make sure you put your units on your AP exam and on exams in class. The second part of the question is this numerical approximation less than the value of the exact area? And explain your reasoning. So what we did is we tried to approximate how much or what the area is by finding the area of this, 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 and this, and adding it together. However, you must note and you must see that there is a difference in the area, I'm just picking color, from the actual curve. There's a difference here, 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 and there. And that is significant to note, you know, whether or not this is going to be an over approximation or an under approximation. In this case, what we find that 3,700 gallons is going to be an under approximation because I am under the actual or the exact area. And we talked about this a little bit in class when we looked at the pattern. Since r prime of t, or my slope, is greater than 0, or it is increasing, right? My derivative is increasing. And anytime we have that, the left Riemann sum is less than the exact value. And that's the answer.